Good morning, ma'am. I am Harshit from 2nd ECE. Today's my topic is solving for 0 less than mod z minus 1 less than 1 and 1 more less than mod z less than 2. My roll number 234g1a0443, 2nd ECE A. Analysis of f of z is equals to 1 by z cap 2 minus 3z plus 2. In specified regions, solving for 0 less than mod z minus 1 less than 1 and 1 less than mod z less than 2. Problem statement. State the function f of z is equals to 1 by z cap 2 minus 3z plus 2. Regions of the interest. 0 less than mod z minus 1 less than 1. 1 less than mod z less than 2. Now let's discuss about the factorizing the denominator. And then factorize z power 2 minus 3z plus 2 into z cap 2 minus 3z plus 2 is equals to z minus 1 into z minus 2. Rewrite the function f of z is equals to 1 minus z minus 1 z minus 2. Partial fraction decomposition. Use partial fractions f of z is equals to a by z minus 1 plus b by z minus 2. Solving for a and b. A is equals to 1, b is equals to minus 1. Final decomposition f of z is equals to 1 minus z minus 1 by 1 by z minus 2. Region 1. 0 less than mod z minus 1 less than 1. Explanation of the region. Z minus 1 measures the distance from z to 1. 0 less than z minus 1. 1 implies z is near 1 but not equal to it. Series expansion for 1 by z minus 2 in 0 less than z minus 1 less than 1, mod z minus 1 less than mod z minus 2. Expand 1 by z minus 2 as a geometric series. 1 by z minus 2 is equals to minus 1 by 1 minus z minus 1. 1 by z minus 2 is equals to minus sigma z minus 1 whole power n. Series for f of z in z 0 less than mod z minus 1 less than 1. Substitute into f of z is equals to 1 by z minus 1 minus 1 by z minus 2. F of z is equals to 1 by z minus 1 plus less than sigma z minus 1 whole power n. Region 2. 1 less than mod z less than 2. Explanation of the region. Mod z measures the distance from z to the origin. 1 less than mod z less than 2 implies is between the circles of radius 1 and 2. Series expansion for 1 by z minus 1. In 1 less than mod z less than 2, mod z less than 1 mod z. Expand 1 by z minus 1 as a Lorentz series. 1 by z minus 1 is equals to 1 by z into 1 by 1 minus 1 by z. 1 by z minus 1 is equals to sigma 1 by z power n. Series expansion for 1 by z minus 2. Similarly, expand 1 by z minus 2 is to 1 by z minus 2 is equals to 1 by z into 1 by 1 minus 2 is by z. 1 by z minus 2 is equals to sigma 2 power n by z power n. Series for the f of z in 1 less than z mod z less than 2. Combine the expansions. F of z is equals to sigma 1 by z power n minus sigma 2 power n by z power n. F of z is equals to sigma 1 minus 2 power n by 2 z power n. Comparisons of regions. Show the differences in series expansion for two regions. Region 1. Centered out around the z is equals to 1. The series expansion converges for 0 less than mod z minus 1 less than 1. Region 2. Centered at infinity Lorentz series. The Lorentz series converges from 1 less than mod z less than 2. Graphical representation. Visualize the two regions on the complex plane. Region 1 annular region around z is equals to 1. Region 2 annular region centered at z is equals to 0. Convergence of series. Region 1. The series converges when z minus mod z minus 1 less than mod z minus 2 into z mod z minus 1. Mod z minus 1 less than mod z minus 2. The convergence realizes on mod z minus 1 less than 1 into mod z minus 1. Reason 2. The Lorentz series converges for 1 less than mod z less than 21 less than mod z. Convergence is based on the relative magnitude of the mod z to 1 and 2. Applications of series expansions. Explain the practical uses of such series expansions in the solving. First one is solving differential equations and second one is analyzing complex functions. General formula recap. Recap the series formulas derived. Reason 1 and reason 2. In reason 1, f of z is equals to 1 by z minus 1 plus sigma z minus 1 n of f z is equals to 1 by z minus 1 plus sum of z minus 1 n f z is equals to 1 by z minus 1 plus z minus 1 n. Reason 2, f of z is equals to sigma 1 minus 2n zn f of z is equals to sum 1 minus 2 power n z power n nf of z sigma 1 minus 2n by zn. Error analysis. Error in transiting series. Approximation errors arise from the limiting number of terms. In the expansion of increasing terms reduces the error, but requires more computation. Error reduction techniques use computational tools for higher precision. Challenges in analysis. Difficulties in performing series expansion manually. Importance of computational tools. Conclusion. Explore f of z is equals to 1 by z2 minus 3z plus 2. F of z is equals to 1 by z cap 2 minus 3z plus 2. F of z is equals to 1 by z2 minus 3z plus 2 in two regions. Derived and analyzed series expansions. Thank you, ma'am.